Hi, welcome back to my channel, Physics from 5 KSSM. We continue Chapter 2 Pressure on topic 2.2 Atmospheric Pressure. In this video, I will discuss two learning standards. The first one is to describe atmospheric pressure. The second one is communicate about the value of atmospheric pressure. Let's get started. What is atmospheric pressure? I hope you still remember what we have discussed earlier about the meaning of pressure. And then we have discussed about the concept of pressure in liquids that caused by weights of the liquids. So in this topic, we want to discuss on atmospheric pressure. When we talk about atmospheric pressure, it refers to atmospheric layer that surrounded the Earth. Okay, what is atmospheric pressure? Atmospheric pressure is the pressure due to the weight of the layer of air acting on the surface of the Earth. As we know that molecules of air also have its own mass. So the mass of the air in atmospheric layer will exert weight on the surface of the Earth. Look at the diagram here. The Earth is surrounded by a thick layer of air consisting of various types of gases. This one refers to atmospheric layer surrounding the Earth. This layer of air has weight and exerts a pressure on the surface of the Earth as well as all objects on it. You can see all the air molecules. Due to its mass, it will exert weight on your object or on the surface of the Earth. So what happens to the objects? All objects on the surface of the Earth will experience atmospheric pressure. As you can see, atmospheric pressure is caused by the air that surrounded the objects. Thus, atmospheric pressure acts in all directions to the object which is in atmospheric layer. You watch this video, how we can prove that there is atmospheric layer. So look at this one. Actually, the can, this big can is filled with water. Boil the water until you can see the steam coming out from the opening at the top here. Okay, when the water changes to steam, the steam that come out here will displace the air molecule in the can. So meaning the can now is filled with steams. So the pressure in the can is very high because the steam has a properties as a gas will collide with the wall of the can and produce higher pressure inside the can. Now they remove the fire from the can, meaning stop applying heat, and then close all the openings at the top here to prevent the steam from release out from the can. So the inside the can, the pressure is very high. Okay, what happened next is use cool water to cool down the can. So what happened is the steam in water will be cooled down, thus change back to water by process of condensation. So this one will cause collision between molecules of steam with the wall of the can decreases, the pressure decreases. The higher pressure outside, which is atmospheric pressure, which is very, very high as compared to the inside the can, will crumple the can. So this is actually the activity that proves there is higher value of atmospheric pressure that acts on the can. Okay, so I think this is already become a proof a proof for existence of atmospheric pressure. So why is the hot container crumple? So atmospheric pressure is greater than the pressure in the container, causes the can to crumple. Okay, you can refer to your textbook, activity 2.4. In this activity, the aim is to discuss atmospheric pressure from the aspect of the weight of the air acting on objects at the surface of the earth. As the first example is a diver dive to a certain depth in water. The concept of pressure in liquid that we have discussed, that pressure in liquid is caused by weight of water column acting on him. So this diver will experience pressure in liquids in all directions. Okay, let's look at this one. Atmospheric pressure is caused by weight of air acting on her. Actually, her body is surrounded by air, which is in atmospheric layer. So collision between the molecules of air will exert force on her body. Because of the pressure acts in all directions, so she does not feel anything act on her. We can see something like there is no net pressure acting on the objects. Okay? So this is the proof that there is atmospheric pressure that caused by air molecules in atmospheric layer. Now we want to discuss the similarities and differences between atmospheric pressure and water pressure. We have discussed about pressure in liquid earlier. What are the similarities between pressure in liquid and atmospheric pressure? The first one, the concept of pressure. Due to weight of fluid column acting on the surface below it, meaning pressure is caused by the weight of liquid. Atmospheric pressure is caused by weight of air acting on the surface below it. Okay, both of the pressure acts in all directions. Both of the pressure does not depend on surface area. Both of the pressure depends on density. Both of the pressure depends on gravitational acceleration. Now we look at the difference between pressure in liquid and atmospheric pressure. Pressure in liquid increases with depth. If you still remember the formula, P equals to H rho G. Atmospheric pressure decreases with altitude, meaning height. The higher the position or the higher the place, meaning on top of the mountain, meaning altitude is higher, atmospheric pressure is smaller. This is due to density of air that is smaller, okay, at higher places. Okay, look at number 2. Estimate the atmospheric pressure at the surface of the earth. It is given that the thickness of the atmosphere H equals 120 km. The average density of air rho equals 8.5 times 10 to the power negative 2 kilogram meter to the power negative 3, and gravitational acceleration G equals to 9.81 meter second to the power negative 2. So we are using the same formula because atmospheric pressure is also caused by weight of liquid acting on the surface below it. Okay, so we use the same formula, H rho G. So atmospheric pressure, I write as P ATM equals to H rho G. What is H? H here is the thickness of the atmosphere that refers to air molecules. So it's 120 times 10 to the power 3 because the unit here using prefix kilo. And then the density of air, 8.5 times 10 to the power negative 2, and gravitational acceleration, 9.81. Thus we get about 1.0 times 10 to the power 5 Pascal, or equals to 100 kilopascal. Okay. How can we measure atmospheric pressure? There must be measuring instrument. Let's look at the basic instrument that can be used. The first one is simple mercury barometer. Mercury barometer consists of a 1 meter long glass tube containing mercury. So the first what we do is fill mercury into the tube until at the top part and cover it with lid, fully filled with mercury. And then turn it upside down into the bowl. What we do next is remove the lid. What happened to mercury? The mercury will coming out from this opening and causes the mercury column in the glass to fall until a certain height and remain at that height. So this is what exactly happened. So mercury will drop in the tube to fill out here in the bowl, and then you can see it will fall at certain height. For example, here 760 millimeter, and then stop here. Okay, the space here is vacuum. Okay, so what we can say about this height? If you look at carefully, the height of 760 millimeter will exert force or will exert weight that produce pressure at this point, which is same level as outside here. As we know that for pressure in the same liquid, same level, same pressure. So the outside here is caused by surrounding air, we call it atmospheric layer. So this value of pressure is equals to pressure at this point. And pressure at this point is caused by 760 millimeter. Thus, the pressure outside actually equals to 760 millimeter mercury. So we use mercury as a liquid in this simple mercury barometer. The atmospheric pressure acting on the surface of mercury in the bowl supports the mercury column. If the height of mercury column H equals 760 millimeter, thus we can say that atmospheric pressure equals to 760 millimeter mercury. So we can use this unit to represent unit for atmospheric pressure. How to convert to Pascal? This is millimeter mercury. Sometimes we need to state in other unit, for example, SI unit Pascal. So we can use the formula H rho G. 760 millimeter is the height here, and then we can convert it to meter. So it's 0.76 times density of mercury. Okay, no worries, this one will be given when there is a calculation problem. So 1.36 times 10 to the power 4 times 9.81. Thus we get the answer equals to 101,396 Pascal. Or you can write the answer in standard form, 1.01 times 10 to the power 5 Pascal. So this one we call it simple mercury barometer. If you look at the simple mercury barometer, in terms of practical use, it is not suitable because mercury will be easily spilled out. As you know that mercury is a poisonous liquid. So in order to produce a very practical way so that we can bring here and there or handle it easily, so we can have this 14 barometer. Okay, so you can see there are safety features added so that it become safe to be used and easily to handle. So this 14 barometer shown above is a mercury barometer that measures atmospheric pressure to high degree of accuracy. There is a vernier scale in millimeter scale. The 14 barometer has height of almost 1 meter. This instrument is usually used to measure atmospheric pressure at meteorological centers. Okay, so this one is we can bring it can be handled easily compared to the simple mercury barometer. Okay, the next one is aneroid barometer. Looks like a compass, or maybe looks like a stopwatch. What is this? This is aneroid barometer, so we can use it to measure atmospheric pressure. So it consists of a semi-vacuum metal box. This aneroid barometer functions mechanically. The partial vacuum metal box, as shown above, change its size when there are changes in atmospheric pressure. Okay, this one can change its size. The small change in volume of the box is amplified by mechanical system to move the pointer of the barometer. As we know that as there is change in height or altitude, okay, it will cause effect to the volume of the semi-vacuum metal box. So the change in height will cause the pointer to deflect. So this one will give readings. Aneroid barometers are suitable to be used in homes, ships, and aeroplanes to obtain a quick reading of the atmospheric pressure. Other use is to measure altitudes. For example, in aeroplanes, to determine the height of the aeroplane at, so we can use this aneroid barometer to determine the altitude. The differences between 14 barometer and aneroid barometer. Okay, let's look at one by one. The first one, for 14 barometer, the value of atmospheric pressure is determined by changes in the height of mercury column. Okay, as you can see, for 14 barometer, it consists of a glass tube filled with mercury. Aneroid barometer, the value of atmospheric pressure is determined by changes in the volume of partial vacuum metal box. For 14 barometer, it is larger size and not portable. Aneroid barometer, smaller size and portable. 14 barometer takes a longer time to give readings for atmospheric pressure, but it is higher accuracy up to plus minus 0.1 millimeter mercury. For aneroid barometer, it can give direct reading for atmospheric pressure, but lower accuracy up to plus minus 1 millimeter mercury. So to measure a higher place, for example, want to go to the top of Mount Everest, for example, it's not suitable to bring 14 barometer. I think it's better to bring aneroid barometer. So you can see which one is suitable, depends on the situation. Okay, the SI unit of pressure, normally we use Pascal, or equals to Newton meter to the power -2. However, a few other units of pressure are still commonly used in various fields. Study figure below, so we can use various units of pressure. Pascal is known as SI unit for pressure. Used in the field of science, values of pressure need to be converted to the unit Pascal before substitution in physics formula. As you know that when we calculate using a physics equation, we try to use SI unit. Atmospheric pressure at the peak of Mount Kinabalu is about 60,000 Pascal. So how to convert Pascal to other unit? Later we'll discuss in problem solving part. Okay, the second unit that we can use, millimeter mercury, as used in the mercury barometer. Manometric unit of pressure, used in the field of medicine, meteorology, aviation, and science. Blood pressure of 120/80 recorded by doctor is in millimeter mercury. So you can see if you go and measure your blood pressure, so you know this one is 120 millimeter mercury over 80 millimeter mercury. Next unit is meter of water, mH2O. H2O is water. So meter of water. This is a metric unit used for pressure of water in the sea, water reservoirs and dams. Water pressure in the Bakun Dam is 150 meter of water. Okay, meaning the depth is 150 meter. So at the bottom part will be 150 meter of water. Millibar or mbar, a smaller metric unit used in the field of meteorology, equivalent to unit hectopascal or HPA. 1 millibar equals to 1 hectopascal or atmospheric pressure is 1.1013 millibar. Okay, so these are the units that you will meet in this section or in this chapter, especially in the calculation problems. Okay, so normally is we use a unit Pascal, but sometimes they will give you other unit, metric units. So you must get familiar with the unit for atmospheric pressure. So for this part, I will stop here. I will continue with in my next video about problem solving involving atmospheric pressure. Okay, bye.